Two-tailed tests. Two-tailed tests arise in situations where the null hypothesis is that a parameter is equal to a certain value, and the alternative hypothesis is just that it isn't that value. The critical region is now at both ends because we don't know whether p is less than or more than, we just suspect that it's not equal to. Suppose we had the null hypothesis that p was 0.4. We are testing whether the parameter is not 0.4 so that the alternative is p is not equal to 0.4. We do an experiment with 11 trials. We need to identify the critical region, say for 5%. We split this so that it's 2.5% at each end. So, at the top end, we can see that this is not there yet, so that's going to be 0.07%. That's 0.59%. That's 2.93%, which is more than the 2.5%. And so we would go in here. Now looking at the other end, this is 0.36%. This is 3.02%, which is more than our 2.5. So we go in here. The actual significance for this test is just 0.36. Add 0.59. The critical region we've now identified is the value x equals 0 and x is greater than or equal to 8. And so the acceptance region are the values from 1 to 7.